Hey everybody, this is Professor Forsyth. If you guys could, there's like a raise your hand option or button. If you could raise your hand, let me know that you can hear me. Then we can go ahead and get started. Or if you can type in the question box that you can hear me, then we can get started. Can you guys hear me? Can you guys hear me? Just let me know, because sometimes I can think you can hear me, but you actually can't. So if you could raise a hand or type in the chat box, the best way for this to work is if it's interactive, so I can know you're here with me. Okay, I see a question. Awesome, thank you. I see one person, they can hear me. Awesome. Okay, so this is going to be a quick review session. I basically have questions from a test review that's in your Blackboard course, and I hope that everyone, if they have not started to work on it, they will very soon. Remember that you can take that test review as many times as you would like, and if you can get at least an 80% on it at some point, then you will earn 5 extra bonus points on your actual test 1 grade. So it's an awesome opportunity to get extra credit just for studying for your test. So please be sure and do that. Okay, let me just check a few things and we're going to get started. Okay, so feel free if you have a question, because it's difficult for me to see everything that you guys are asking while I'm teaching or while I'm working. So I think you can unmute yourself. So if you have a question or you want to stop me, just unmute yourself and just, say something so I know. So right now it's just 3 of us total here today. So, feel free to use this time as best as you want. Okay, so let's get started. I'm going to move my clock because I don't want you to hear the tick, tick, tick. Okay, so let's see here. All right, so number 1, solve the inequality. Give the solution set in both set builder notation and graph form. So we have an OR compound inequality. So let me get my pen. Okay. All right, so first we're going to solve each inequality separately. So we have x minus 2 is greater than 1. So we're going to start by adding 2 to both sides of this inequality. I'm going to bring down that x, negative 2 plus 2 cancels out to 0. X is greater than 1 plus 2, which is 3. Just as a review on the side, remember this symbol means greater than. You can hear outside. That's what's going on. This is less than. And then if we have a greater than or equal to, this line here tells us that it's greater than or equal to. And then this would be less than or equal to. All right. Somebody's cars are very noisy. Okay, so just to be clear on those inequality symbols. So we have our first inequality solved. We're going to do the next one. So x plus 2 is less than 1. We're going to subtract 2 from both sides. So I'm going to bring down that x. Excuse me, 2 minus 2 is 0, is less than 1 minus 2 is negative 1. So I have 2 inequalities. Now let's first look at the graph. So I'm going to start with a number line. Negative 1 will be on the left, and 3 will be over here on the right. Let's start with x is greater than 3. Excuse me. Okay, x is greater than 3. So that means that we are not going to include 3. It's just greater than, not equal to. So we're going to use an open circle, and then x is greater than 3. Excuse me, guys. X is greater than 3. All the values greater than 3 are going to be to the right. All right? Now, x is less than -1. We're going to use an open circle for that, and we're going to shade less than -1. Now, since it is an OR inequality, we want all the possible solutions. We don't have to have the intersection. So the actual solution would be everything that you see shaded here. So that would be the graph form. Now, set builder notation would look like this. Just 1 second. 1 second. Sorry about the interruption. Okay. So like I said, the graph will look like this. Now also, I want to say in your textbook, you guys use parentheses and brackets. So where I have open circles, you would use parentheses. And then where I have, if I had a closed circle, which would represent it being equal to, you would use a bracket. So to use the parentheses or bracket on the graph, we would use a parentheses here and then shade this way. So the parentheses is the same as having an open circle. And then we would have parentheses this way and shade to the right. So I'm just graphing the same graph but using a different symbol, which would be parentheses. And then set builder notation is really just writing your solutions, their inequalities, in a set form. So we would use these little squiggly bar, and we would say all values for x such that, that's what that means, x is, and we'll start with the smaller number, is less than -1, or x is greater than 3. All right. Okay, let's see here. Yes, do you have a question? Let me check the question box. I see a hand. Do you have a question? Can I unmute you? You want me to unmute you? Let me see. For 1 second. Okay, I unmuted you.
Yes, I tried to do that same thing to one of the answers in one of the homeworks where the bracket, and it wouldn't take it because that was one of the lessons that I had, and for some reason it did not want to take it as an answer.
Do you know the exact, like, can you tell me what section? I can look it up.
Yeah, I was like, well, I did it right. I know I did it right, and then it just wouldn't take it as an answer.
It's probably in 8.2. Let me see. Okay, now, in this homework, it looks like most of them are asking for interval notation. And that's a different notation, and we can do that here. Okay, I'm going to do just so, but thank you for that question.
All right.
Okay, so Awesome. I'm looking at your homework, and I believe those were asking for interval notation. So basically, there's two different ways you can express the same thing. So set builder notation is one way, which is what I wrote here, and then interval notation is a different way. So, and you're going to have some questions on that, I believe. So let me do that just under here. The nice thing is that to me, the graph helps you write interval notation easier. So, for example, all right, so I'm going to draw a graph again, a number line. So this number line represents all the numbers in the real number system, not just -1 and 3. So if we think back, the most negative of negative numbers, the smallest number, we don't know that, but we know that we're going to basically say everything going to the left is going towards negative infinity. And then everything going to the right, the biggest number goes to positive infinity. All right. So now let's look at our graph that we had. So we had it shaded over here, and then with the parentheses, and then parentheses and shaded to the right. So interval notation will look like this. So we want to express these shaded regions as intervals, okay? So we always think left to right. So starting from the very left, based on what is shaded, we're going to actually start with negative infinity. And you always use parentheses by any infinity, whether it's positive or negative, because it's not a defined number, right? So a bracket is there to either say we are including this or we are definitely stopping here. Or for infinity, that's infinity. So we always use parentheses. So from negative infinity all the way to -1. So we're going to use parentheses, -1. And since we are not including -1, we're going to use parentheses for that. And I don't like how that looks. Let me try that again. So this interval here represents this interval here. So that's what that interval represents. Now, we also have another interval for our solution, this that we have shaded on the right. So we're going to write a U because that means the union, we're including something else also. So expressing this interval here, it starts at, you always go left to right, it starts at 3 with the parentheses because we are not including 3, and it's going all the way to positive infinity or just infinity. And then like I said, you always use parentheses for infinity. And so this shaded region here is represented here. So the solution in interval notation would be what we have here. The solution in set builder notation would be what we have here. You're basically saying the exact same thing. It is describing the same solution, but with a different type of notation. So that's what that was about. And I know I've had questions about, you know, already in terms of making up homework. Just so you guys know, I do always drop at least 3 homework grades at the end of the semester, or at the end of the course. And I always drop, I think I'll probably drop 1 quiz grade. So in the event that you have, you know, that section, and that's per section. So for example, you had, I think, you had 4 homework sections in week 1, and you have 3 homework sections in week 2. You usually don't have more than 4. For the most part, you're going to have 3 sections. So just kind of know if you have that section that didn't happen, you didn't get the points that you wanted, I'm going to drop at least 3 at the end of the semester. So that may help kind of ease your worry. Like I know, you know, this student, I know you weren't able to answer those. That won't be the, you know, make or break your B or A. So hopefully that'll give you some comfort with that. Okay, so that was question number 1. So we're going to move on. And I may jump around. I kind of have questions similar to the test, but I may just kind of jump around. So actually, I think I am going to go to another problem just so we can kind of see a lot of different types. Also, I'm going to post this video on our Blackboard course later today. In addition, there is another review session video on your Blackboard course that you can review also that matches the paper study guide that's posted. So if we don't get through every question here, you do have another video session that you could watch to help you out. So solve the absolute value equation. So for this problem, you're going to set up two different equations to solve. So we're going to write the left side of the equal sign the same, but drop the absolute value signs. So we have 2s plus 2, okay, equals, go away. That's crazy. Let's see, I want this to go away. Okay, equals, and then now we're going to write the right side of the equation just as it is without the absolute value. So it's s plus 6. Then the other equation, we're going to write the left side the same. 2s plus 2 is equal to, then negate the right side. So negative times s plus 6. So now we have two different equations that we're going to solve. So we want to put our variables to one side of the equal sign and our constants, our numbers, to the other side. So I'm going to subtract s over here, and so subtract s on the left. So remember, for an equation, you want to keep that equation balanced. Think about this equal sign here as like a balance beam. So if you subtract s, or subtract anything from the right-hand side of that balance bar, you have to subtract that same thing from the other side of that balance bar to keep your equation balanced. So that's why we are subtracting s on the left, because we did it on the right. And the reason why we did it on the right is because I want to move all of my variables to one side. And I decided I want my s variables to be on the left side of the equal sign. You could have moved 2s to the right side if you wanted to, but I decided to make my s's go on the left. Okay, so 2s minus s is 1s plus 2 equals s minus s is 0. That's why I did that, because I only want to have this 6 on the right. Now 1 times s is the same thing as s, and now that I move my s's to one side, I'm going to move this 2 to the other side. I don't want this plus 2 to be here with the s. I want that to go away. So I'm going to subtract 2. But again, got to keep this equation balanced. If I subtract 2 on the left, I got to subtract 2 on the right to keep it balanced. So now 2 minus 2 is canceled out. That's 0. I'm going to bring down my 1 times s, which is basically s, equals 6 minus 2 is 4. So that is one part of my solution. Now I'm going to take care of the other solution. So before I start moving variables and numbers, I'm going to distribute this negative. So that's going to be negative s minus 6. And I'm going to rewrite the left-hand side. So now, same thing. I want to move my s terms to one side, my constants to the other side. So I'm going to add s to both sides. 2s plus s is 3s. Bring down that plus 2 equals negative 6. Then I'm going to subtract 2 from both sides. 3s equals negative 6 minus 2 is negative 8. Then I'm going to divide by 3 to get s by itself. So s equals negative 8 over 3. So these are my two solutions. You are often going to have two solutions when you solve an absolute value equation. All right? Okay, so let's keep going. Graph the linear equation by finding and plotting its intercepts. Okay, so when you find intercepts, so remember that an intercept is where your line crosses that particular axis. So the horizontal axis is your x-axis, and the vertical axis is your y-axis. So where your particular line crosses each axis, that is your intercept for that axis. All right. Okay. So to get let's start with the x-axis. So to find the x-axis, the x-intercept, sorry, you want to make or set y equal to 0. So you're going to make the opposite variable 0. So to get the x-intercept, you make y equals 0, and then solve for x. So we would say negative x plus 4 times 0 equals negative 4. So 4 times 0 is 0, so negative x plus 0 equals negative 4. Negative x plus 0 is negative x equals negative 4. But I want to find positive x, so if I, let's see, multiply both sides by negative 1, that will give me a positive x on the left, and then negative 4 times negative 1 is positive 4. So this is an x-intercept. And if I wanted to write it as an ordered pair, that would be 4, 0. So let's plot that intercept. So remember, the intercept is on the actual axis, and it's an x-intercept. So I'm going to go to 4 on the x-axis and plot that point. Now, to find the y-intercept, you're going to make x equals 0 and solve for a y. So I'm going to have negative times 0 plus 4y equals negative 4. Negative times 0 is just 0, plus 4y equals negative 4. 0 plus 4y is 4y equals negative 4. And then to solve for y, we'll divide by 4. So y equals negative 1. So if I want to write that as an ordered pair, that would be 0, negative 1. So let's plot that intercept that is on the y-axis because it's a y-intercept. So I'll go to negative 1 on the y-axis. And all you need is at least 2 points to graph a line. I have my 2 points. And my line will look something like that. Okay. All right. Any questions on that one? Okay. Number five. Excuse me, guys. I'm so sorry. Find the slope and y-intercept of the line. So this is asking you to use one of the most popular, I guess, forms in algebra, and that's the slope-intercept form. So what is slope-intercept form? That is y equals mx plus b. This is a very helpful form because it gives us 2 very important characteristics or items or information about a line. So m is going to be your slope, and b is your y-intercept. So if you can make your equation turn into slope-intercept form, basically solve it for y, get y by itself, and put it in this form here, then you will be able to just identify the m and the b and identify what the slope and y-intercept would be. So we're going to take our equation and we're going to set it equal to y. So here's y right here. I want to get that, oh goodness, didn't mean to do that. Sorry guys. Sorry about that. Okay, so here's y right here. I want to get this term by itself. So I'm going to start by adding 4x so that this negative 4x will go away. But if I add 4x on the left, I need to add 4x on the right. So now I bring down that 5y. Now I just have equals. Now since I want it to be in slope-intercept form, I want to put my x term first. So I'm going to write 4x. Then I'm going to write minus 45. Now I need y to be completely by itself. It's not by itself yet. I have 5 times y. So to get y by itself, I'm going to divide by 5. And if I divide by 5 on the left of the equal sign, I have to divide everything by 5 on the right. So I'm dividing this term and this term. So 5y over 5 cancels out to just y equals 4 over 5x, and then negative 45 divided by 5 is negative 9. So now take a look at your slope-intercept form, y equals mx plus b, and look at our equation now. You should see that it is in the same form. It's just that you have numbers in place of your m and your b. So the m is the coefficient in front of the x. That's your slope. So the slope of this line is 4 over 5. And then the y-intercept is b. In this case, include that negative. Remember, the sign goes with the term right after it. Your y-intercept equals negative 9. And you may have to write that as an ordered pair because that's a point. So that would be 0, comma, negative 9. Okay? And sometimes it will ask you just for that y coordinate, so you could just write negative 9. But if it asks for an ordered pair, you need to write this. So this is an ordered pair. Okay? But that's your answer. Okay, so now write the equation of a line through the given points in slope-intercept form. Okay, so again, it's slope-intercept form because you have to, it tells you what the slope and the y-intercept is. So if you're going to write an equation in that form, you need to find that information. So you don't have any of that right now, but you do have 2 points on a line. So if you have 2 points on a line, you can find the slope of that line that passes through those 2 points. So the slope formula, we refer that as y2 minus y1 divided by x2 minus x1. This is the formula you use to find the slope of a line when you only have 2 points on that line. So the small 2 and the 1s just represent that we're talking about 2 different points. So it may help you to label your point. So like 9, negative 1, that could be considered point 1, like point number 1. So we'll say that's like x1 and y1. And then the second point, we can make that x2 and y2. So all the 2 and the 1 is there for is to kind of help you plug in values. So if we're following the way we labeled our points, we would say negative 4 minus negative 1 over 5 minus 9. Be very careful with those negatives and the minus. So for example, it was y2 minus y1. So we were subtracting a negative. Include all those symbols. All right? So now, negative 4 minus negative 1 is going to give me negative 3. And then 5 minus 9 is negative 4. Now, you don't want to leave a fraction with a negative divided by a negative. You want to simplify that and make that positive 3 over 4. So we just found the slope, but that's only half of what we need to get our equation. So we're going to use another form to help us get to that equation, and that's point-slope form. And this is a really helpful form because all you need when you're using this form is, what do you think? A point and a slope. So we have the slope. We have the slope, that's 3 over 4. We actually have 2 points we can use, so we just pick a point. It doesn't really matter. So the point-slope form is y2 minus y. No, wrong formula. It is y minus y1 equals m times x minus x1. The x1 and y1 does not have to be the same x1 and y1 you use to get the slope. That's just using one because there's only one point being used here. So you could use either one of these points for your x1 and y1. Just to make this make sense, I'm going to use what we labeled for x1 and y1, but you could use 5 and negative 4 if you want to. So basically, this value, x1, is going to come from your point, and y1 is going to come from your point. And we already have the slope. That's going to be what we found earlier. So let's plug in our values. So we have y minus negative 1. Let me use some colors here. Equals m, which we know is 3 over 4, times x minus x1, which is 9. Okay, so y minus 1 is y plus 1 equals, and now we're going to distribute the 3/4. So 3/4 times x is 3/4 x, and then 3/4 times negative 9 will be negative 3 times 9 is 27 over 4. And then we need to add the 1. All right, so we're going to add 1 to, no, I'm sorry, subtract 1. We're going to subtract 1 from both sides. Now, we need to do, let's do this over here on the side. Negative 27 over 4 minus 1. You can put that in the calculator since you can use one in this class, and that's totally fine. You also can do it by hand. So a negative plus a negative is going to give you another negative. So I'm going to ignore the signs and just know that my final answer is going to be negative. So 27 over 4 plus 1. I need to get common denominators. I want to get a denominator of 4. So 27 over 4 plus something over 4. So what would equal 1? What's divided by 4 would equal 1? 4. So 27 over 4 plus 4 over 4 would be 31 over 4. So now I can finish up my equation. That's y equals 3 over 4x. And remember, that's negative 31 over 4. Or you can also put that in the calculator. You totally can do that to get your answer as well. And just to make sure you know how to do that, I'm going to actually find an online calculator. I believe there's one I can use for you right now. Let me see here. TI-3. Yeah. Actually, we already have it. Let's see something real quick. No, I don't. Okay. Do I have a calculator? Nope, I don't. All right. So, I'm going to see if I can download it. Did have it. Okay. Here we go. Okay, cool. So let's put in our negative 27 over 4 minus 1 in the calculator. So I would put all of my, oh, I need to change, sorry. Okay. All right, so I'm going to put my fractions in parentheses. So parentheses, negative 27 divided by 4, close parentheses, minus 1. So if I press enter, that's going to give me a decimal. Well, I don't want a decimal. And this is going to be a lot of multiple choice questions on here. So if your answer does not have decimals, you don't want to look for that, obviously. So how can I change this to a fraction in the calculator? It will do that for you. If you press math, so as soon as you get your answer, you want to change it to a fraction. If you press math and choose that first option, a fraction, it's going to take whatever you recently had, your last answer, and change it to a fraction. You press enter, there you go. So don't sleep on using the calculator. It can be your friend. It can help you get through these problems a little quicker, save some time, okay? You can use it on the test. So get familiar with it. I would suggest that you purchase one, especially if you're going to take any math beyond intermediate algebra. We also have them here at the depot. You can check out for 4 hours. They're great. Okay, so let's keep going. Okay, so write an equation of the line and write it in slope-intercept form. So our equation, it goes through this particular point of negative 4, 12, and it's perpendicular to 5x plus 7y equals 63. So remember, parallel lines have equal or the same slopes. Perpendicular lines have what's called opposite reciprocal slopes. And what does that mean? You flip it and change the sign. Okay? So here we're talking about perpendicular. So first we need to get the slope of the equation that's given to us. So in order to do that, the best way to do that would be to put that into slope-intercept form. Right now it's in standard form. So I'm going to take that 5x plus 7y equals 63 and set it equal to y. So to start that process, I'm going to subtract 5x from both sides. 5x minus 5x cancels out. I have 7y equals, I want to put it in slope-intercept form. Remember that's y equals mx plus b. I'm going to put that negative 5x first so I can be in the proper form, plus 63. Then I want to divide by 7 everywhere because I'm dividing by 7 to get y by itself. Remember, fractions truly are your friend when you're talking about the slope. So don't try to get a decimal for negative 5 divided by 7. There's no need to do that. So we have negative 5 over 7x, and then 63 divided by 7 is actually just 9. So here's the equation written in slope-intercept form, and the reason why we did that is that we need the slope. Okay? So this equation's slope is negative 5 over 7. Now, if we were writing a parallel equation, then the slope we would use would be the exact same slope as the one I have in red. But we want the perpendicular slope. So that means we have to take what we have in red, the perpendicular slope is going to be the different sign, so it's going to be positive, and then we're going to flip that fraction. So it's going to be positive 7/5. So again, opposite reciprocal means you flip it. So we flipped the fraction and then change the sign. So the slope that we want to use is going to be 7/5. Okay? We have a point to use, -4, 12. So now we can use point slope form. Y minus y1 equals m times x minus x1. We can use the point that was given to us. We can use the slope that we now know, and we can get our equation of the line that we want to write that goes through -4, 12, and it's perpendicular to this equation. So let's plug in our values. We have y minus 12 equals 7/5 times x minus -4. So we have y minus 12 equals 7/5 times x plus 4, because minus and negative just becomes positive. And now before we add 12, we want to distribute that 7/5. So that's 7/5x, and then 7/5 times 4 would be positive. 7 times 4 is 28/5. And so now we're ready to add 12 to both sides. So y equals 7/5x. And just to get some practice using the calculator, let's do that. Where did my calculator go? There we go. Okay. Let's practice that. I have to change modes whenever I do this, so that's why you may hear a little weirdness. Okay. Yes, I want to exit. And I need my calculator. Okay, so I want to do 28/5 plus 12. So I'm going to use parentheses. 28 divided by 5, close parentheses. That's 28/5 plus 12. It's going to give me a decimal. I don't want a decimal, so I'm going to press math, change it to a fraction, press enter, 88/5. So that's going to be 88/5. That's going to be my equation. Y equals 7/5x plus 88/5. Okay? Any questions about that one? Okay. All right, so let's see what else we got. Okay, for the sake of time, I'm going to kind of skip through. Same thing here. This is both in standard form. Change to slope-intercept form. Change them both into slope-intercept form. Y equals mx plus b. And then you want to identify whether those m's in each equation are the same. If they're the same, they would be parallel. If the slopes of each equation are opposite reciprocals, it's perpendicular. And if you don't have either of those things, it would be neither. All right? So you're going to change the slope-intercept form and compare slopes. Okay? All right. Okay, this says determine whether the relation is a function. The easiest way to determine this would be if your x values repeat and they give you different y values. So this is a set of points. And so we have -5, 4, -3, -7, 2, 6, and 2, 4. So you see right here, your x value repeats, and it gives you a different y value. This is going to be a red flag, and this is not a function. This cannot happen for this relation to be a function. Okay? Because basically every input must give its own output. So if you were to plug in a value for x, it should only give you one y. Now you could get multiple x values could give you the same y value. That's okay. But multiple x values can't give you the same x value cannot give you a different y value. So the shortcut way of doing this, we want no repeating x values. If this happens, then it's not a function. Okay? All right, that's how you can tell given a set of points. Now, how can you tell with a graph? So the way that you tell if it's a function looking at a graph is called the vertical line test. All right? So what that means is that if you took a vertical line, can I just make a shape here? Let's see if I can do that. I'm going to make it really thick. Okay. So if you were to take a vertical line, there should not be anywhere where that vertical line will cross the graph more than once at the same time. All right? So the graph here is this parabola. That's your graph. And so what we want to do is take your vertical line and see, is there anywhere that it crosses it more than once at the same time? And the answer is no. All right? So that means that it is a function. Yes, it is a function. Now, an example of it not being a function would be, let's say it was a graph looking like this, for example. And we took our vertical line, and if you look here, there's two places that it crosses the graph on that same line. So this would not be a function. Not a function. So it fails the vertical line test. But this is a yes. Okay? All right. Let's keep the party going. Find the function value. So this is just getting you used to function notation. So find f of x, or find f of 4 if f of x equals x squared minus 2x minus 1. So basically you're going to take this 4, you're plugging it in for x. So everywhere you see x, you're going to put a 4. So f of 4 equals 4. What in the world? Sorry, guys. Okay, f of 4 equals 4 squared minus 2 times 4 minus 1. We're just plugging in 4 everywhere we saw x. And then we're going to just solve. So 4 squared is 16. Negative 2 times 4 is negative 8. Then we have minus 1. 16 minus 8 is 8. Bring down the minus 1. And then 8 minus 1 is 7. So f of 4 equals 7. When you plug in 4, the input of 4 will give you an output of 7. Okay? All right. Find the domain of the function. Write the answer in set builder notation. I feel like I'm just going to kind of teach real quick domain. So in this class, you're going to have two scenarios to check for that would make your domain not be all real numbers. So your domain is either all real numbers, which means your x values can be any value in the real number system, or it could be most of the numbers excluding, you know, a certain value, or it could be a range, a smaller range of numbers. So there's two kind of red flags you want to watch for. So square roots is one kind of red flag, and then denominators is another red flag. So for square roots, you do not want a negative under the square root. No negative under square root. Okay? If that happens, if you have a square root, you want to set what's under the square root greater than or equal to 0 to figure out what your domain would be. Okay? If you have denominators, we don't want 0 in the bottom. If you ever get 0 in the bottom, that's going to be undefined. So we have to exclude any potential x values that could cause the denominator to be 0. If you don't have one of these things happening, then you can say your domain is all real numbers. So like this example here, x squared plus 7 equals f of x. So there's no square roots, there's no denominators. Basically, there is no x value that would cause this function to be undefined. So in this case, the domain is all real numbers. I believe on the test you're going to like type ARN to represent all real numbers. If you were like writing on paper, a lot of times people use this symbol here, like the R with the 2 lines. That means all real numbers. If you want to write that in interval notation, you would say negative infinity all the way to positive infinity. These are all ways of saying all real numbers. Basically, every single number in the real number system would work for this function. Okay, let's see what this next one says. Okay, find the domain of the function. So remember I said you're looking for square roots and you're checking for fraction bar denominators, variables in the denominator. So we don't have any square roots. I do have a fraction bar. So I don't want this. I don't want that to equal 0. Because if I have a number divided by 0, that's undefined. Okay, that's not good. Even if you forget that, you put that in the calculator. Anything, let's see, test it out. Like if I say 5 divided, turn on, 5 divided by 0, it's going to be like, what are you talking about? You can't do that. So we don't want this function to end up with a 0 in the denominator. So what we have to do is figure out, well, how could that possibly happen? All right? So let's see here. So x squared plus 20 equals 0. Let's set the bottom equal to 0 and figure out how that could happen. All right? So if we subtract 20, x squared equals negative 20. And then if we take the square root of both sides, x equals the square root of negative 20. So we don't want to include this value in our domain. Because if we were to plug in the square root of negative 20 in for x, we would end up getting 0. And we don't want that to happen. So for the domain, we're going to say that x is all real numbers except when x is equal to the square root of negative 20. So we don't want to include that. Okay? So this would be your domain in set builder notation. All right? Okay. Find the slope of the line if it exists. So looking at a graph, this is a vertical line. So something to remember with vertical lines. So vertical lines and horizontal lines. Okay, so remember, vertical lines go up and down, horizontal lines go left and right. All right, so the way that I remember this is that horizontal lines, the slope equals 0. Vertical lines, the slope is undefined. And a lot of times it's easy to confuse those. Here's a very silly way that I remember that. So can you walk on a horizontal line? Like if somebody took a line, if you think about it in terms of like the floor, right? You can walk on a horizontal plane. That's the floor, that's the sidewalk, you know, that's the ground under you typically is horizontal. You can walk on that. Can you walk on a vertical plane? Basically, can you walk up the wall? Like just regular walking? No, you cannot walk on a vertical plane. You are undefining gravity or whatever. So that's how I remember which is which. So you cannot walk up a vertical plane, so the slope of a vertical line is undefined. Doesn't matter where it is on the graph. It could be here, it could be here. If it's vertical, the slope is undefined. Horizontal lines, doesn't matter where it is on the plane, the slope equals 0. Okay? All right. So the answer here was, wait, what did I put the answer? The answer here is undefined. That's the slope of this line here, undefined. Okay, solve the problem. The cost of manufacturing a molded part is related to the quantity produced during the production run. When 100 parts are produced, the cost is $300. When 300 parts are produced, the cost is $1,300. Find and interpret the slope of the line representing the change in cost per part. Okay, so what we're going to do, we're going to remember slope is the same thing as rate of change. Okay, so we're going to express what's happening as ordered pairs. So it's kind of like if you want to like graph what was going on. So we have the number of parts and then the cost. So let's say this is 100, 200, 300. So 100 parts are produced, the cost is $300. So that would be like here. When 300 parts are produced, the cost is $1,300. That would be like over here. So what's the rate of change from this point to that point? So it's definitely, is it increasing or decreasing? It's definitely increasing. So that would be how we would describe it. It is increasing by some number. So we're going to figure out how much it's increasing, the rate of change, by finding the slope of this line, basically. So the points we're going to use are going to be 100, comma 300, and then 300, comma 1,300. So to get the slope, we're going to subtract our y values, divided by subtract our x values. So 1,300 minus 300 is 1,000, over 300 minus 100 is 200. And if I divide this, 1,000 divided by 200 equals 5. So basically, it is increasing by $5 per part. Okay? All right, let me do a couple more, and then we'll be done. All right. Oops, sorry about that. Let's see. Okay, another word problem. Laura needs to have her car towed. Little Town Auto charges a flat fee of $40 plus $2 per mile. Find the cost of having a car towed 5 miles. So the way I would think about this is write kind of an equation, right? So the cost, let's say C. So it's C equals the cost, and then I'll say M equals miles towed. Okay, so the cost of getting a car towed equals, it's always a flat fee of $40 plus $2 per mile. And so if we're going to use the variable M for the number of miles, so like if you were to tow the car 1 mile, it'll be $40 plus 2 times 1. If it was towed 2 miles, it would be $40 plus 2 times 2. So we don't know how many miles, so we're going to say 2 times M. So 40 plus 2M will describe how to figure out the cost of towing anything depending on the number of miles towed. So now they tell us that they want to find the cost of having a car towed 5 miles. So that means that we're going to make the number of miles equal 5. So we're going to plug that in our equation. So the cost equals 40 plus 2 times 5. So 2 times 5 is 10. So we have 40 plus 10, which is 50. So the cost would be $50. Okay. Okay, let's look at this next one. So here, the cost of having a car towed. Very similar problem, actually, except that you are given the linear function. The cost of having a car towed is given by the linear function C of x equals 2x plus 50, where C of x is in dollars and x is the number of miles the car is towed. Find the cost of having a car towed 15 miles. So 15 miles is going to be your x. So we're going to plug in 15 in for x. So we're finding C of 15. That'll be 2 times 15 plus 50. So 2 times 15 is 30 plus 50 equals 80. So the cost of having the car towed 15 miles would be $80. Okay. Use the graph of the function to answer the following questions. So find f of -1, and then find x when f of x equals -1. This is basically trying to get you to find x and y values. Let's do the first one. And I wanted, okay, f of -1. That's asking you what is the y value when x equals -1. That's what that is asking you. So you go to -1 on the x-axis. So here it is. So what is my y value along this line here at -1? The y value would be 0. It's right there. So f of -1 equals 0. Okay? Now, let's do the other one. Find x when f of x equals -1. This is asking you what is x when y equals -1. So go to the y-axis at -1. There it is. When y is -1, your graph is at x equals 0. So at f of 0, so f of x equals -1, we just found what x is. So the answer here would be 0. Let me just write it like that. It would be 0. Let's do another one. I'm just going to make one up. Find f of f of 2. So that means, what is my y when x is 2? So here's x equals 2. Where's my graph along the y-axis? So here's my graph here at, erase that. When x is 2, my y would be 3. It's right here. So the answer here would be 3. If I were to do another one, find x when f of x equals, here's one, 3. No, we already did that. Let's do trying to find a good one. 2, 3. When f of x equals 0. We'll do that. So that means that what is my x when y is 0? So you would go to the y-axis, y at 0. That would be a horizontal line going through 0. Your graph is actually touching it 2 places. It's touching it here at 1 and -1. So the answer here would be -1 and 1. So these are made up questions here in the blue and the purple. I just wanted to kind of practice it a little more with you. Okay, so match the graph of the function listed. Basically, guys, you want to memorize what these look like. That's the best way to do it. That is a page in your textbook. So this is actually the cube function. That's the cube function, which typically looks like f of x equals x to the 3rd. It would look like this. Your linear function is a kind of just straight line. Square or quadratic function is a parabola. So let's go through them really quick. So we've got, go back to my blank. All right, so your linear function is just a straight line. Square or quadratic function is a parabola. It could be going up, down, left, or right, but that is a parabola. Square root function looks something like that. Cube root function looks similar, but it looks like that. This is E, your cube function. F is your reciprocal function. That looks like this. And then G, your absolute value function, is a V. So you just want one of those basic function graphs. You don't have to know any transformations or anything right now, just the basic shape of the graph. You want to know these. And then use a graphing calculator to graph the function. So here she is. So f of x equals 1 minus x. So to graph any function in the calculator, first of all, you want to set it equal to y, which in this case, f of x is the same thing as y. So that's like saying y equals 1 over x. Okay? So to graph a function on the calculator, you want to, of course, turn it on, And then you want to go to y equals. Okay? Y equals is where you're going to put your function. So I want to put y equals 1 over x. So I'm going to put 1 divided by, here's your x here. I'm going to say graph. Depending on where your window is or how the window looks, you may see your graph. In this class, if you can't see your graph, but you know you put it in there correctly, the best way to get the window to fit how you want to view your graph would be to say zoom and then standard. So you could say zoom 6, or you could scroll down to that option. And that basically gives you that standard -10 to 10 x values, -10 to 10 y values. But that's your graph. And so you would basically, for this test, you're not going to graph anything on the computer, but you would probably do a matching for this problem. All right? So that's a very quick and dirty review for the test this week. Your test, you need to take that by Monday. Depending on what testing center you're planning to go to, a Valencia testing center, those hours vary. So you want to know what those hours are. I can only kind of vouch for Osceola because I'm at Osceola campus, but definitely keep in mind, don't wait till the last minute. If you come too late, they won't let you start the test. So it is due by Monday. You have Monday as the last day you can take it. Do that test review as many times as you want. Try to get an 80% at some point. Strive for higher, but if you get that 80% at any point, that will give you those 5 extra bonus points for your test grade. You can use a graphing calculator. You may not use any notes. Yeah, so that's pretty much it. So if you have any questions as you work on this, feel free to contact me. Come down to the depot here at the Osceola campus to get tutoring. It has not been very busy, so you would have a high chance of getting a lot of time with a tutor if you needed that. So we're in building 4, room 121. This is also where my office is if you want to stop by and say hi. But you know how to reach me if you have any questions. It's been a pleasure working with you today, and I'm going to post this on the Black Girl course in a few hours after I take out a few edits and make it clean up a little bit and put it on YouTube. So are there any questions before we log out? Let me check and see. If not, I hope you guys have a wonderful rest of the week, and I will talk to you soon. Thanks so much, guys. Bye.